Today we're going to talk about some domains. We talked about a lot of domains the last couple days when we were talking about parent functions, but we really focused on the graphs, okay? So today we're going to kind of focus on either sentences or inequalities or things like that, okay? First of all, I want to let you know that the examples in this section are excellent examples. So when you're going through the problems, at the top during the instructions, it might say, see example 3. And that would be a great thing for you to do, is go see example 3. That might help answer some of your questions. Okay? But before we get started, I want to go through the chart that's on page 4 with you. Okay? The chart that's on page 4 says this. Natural. Now, it doesn't have any numbers in there, so I'm going to put numbers in here real quick so you know what I'm talking about. Natural numbers are sometimes called counting numbers. When you were taught to count, how were you taught to count? 1, 2, 3, 4, and so on, right? Okay? So those are all contained in natural numbers. But outside of that, including all the natural numbers, are whole numbers. What is included in whole numbers that's not in natural numbers? There's only one thing. Who said it? 0. Yeah, 0. Because when you were taught to count, they didn't teach you 0, 1, 2, 3, 4, did they? They just started at 1. So whole numbers include all the natural numbers and 0. Then we have a thing called integers. Okay? What's included in integers that's not in whole or natural? Negatives, absolutely. So -3, -2, -1, and so on. Numbers like that. Okay? And then, right outside of there is rational. Rational numbers. What did we learn day before, that rational meant? Ratio, which is also a fraction. So these are all numbers that can be written as a fraction, right? So like 1/2, 0.5, 2/3, things like that, right? Over here are irrational numbers. If a rational number is a number that can be written as a fraction, what's an irrational number? Number that can't be written as a fraction. That's exactly right. Can you give me a number, an example of an irrational number? Pi. Absolutely. Here's one you're going to learn this year. E. I know that people have told you that your whole life that E is a letter. That's because it's true. But we, in Algebra 2, also use the number E we use the letter E to represent a specific number. Okay, and we'll talk about that when we get there. Okay? But what about like the square root of 3? Do you know the square root of 3? Neither do I. Okay? So those are all rational numbers. And all of this is in a group called real numbers. Now, somebody earlier said, wait, if there's real numbers, does that mean there's fake numbers? Well, while that is logical, because those are opposites, there are not fake numbers, but there are imaginary numbers. That's a little bit more foreshadowing for things to come. Okay? So if in your homework it asks you to do whole numbers less than 10, that asks us to list whole numbers less than 10, what are the whole numbers less than 10? 0, 1, 2, 8. Wait, do we have 10?
No.
Why not?
Because it's less than.
What would make it be 10? Less than or equal to 10, right? It only says less than 10, so we're done. And it's asking for the set of whole numbers that are less than 10. So that's why we use these set brackets right here. Okay? These are set brackets. Does that make any sense?
Yes.
Now, some people earlier were like, that's so many numbers. My response was, right over here. Look right over here. There's Kleenex on my desk if you're going to cry. Okay. All right. I have some wraps for your wrist if you get writing too many numbers. Okay. I could always pull out my midterm for my last class. Would you guys like to see that? It was 65 pages long. So to write a little list like this of numbers, I'm not going to feel sad for you. Okay? Now, some of the other problems on your homework say, it'll say something like x is less than 58. How do we write this in interval notation? This is in Set Builder. Oh, let me actually teach you one thing before I ask you that question. It might look like this. Is that right? Yeah. What does that mean? A lot of people get confused by this. Well, did you know what it meant when it was like this? Yeah, then you know exactly what it means like this, because it's telling you, hey friends, we're going to use an X. This is a mathematical symbol. It's a vertical line. It means such that. So it's telling you, hey friends, we're going to use the X. And here's the inequality we're going to use. That's all it is. That's all it means. So if we were writing that, this is set builder notation. If we were writing this in interval notation, everything less than 58, I want to give myself a visual on this. Here's 58. Here's 0. Everything less than 58, is that a good number line drawing? See, I know you're amazed at how good of an artist I am. You don't have to tell me that's okay. Okay? How do we write this in interval notation? So some of you are looking at me like, I think I know the answer, but I don't know that word. Right? Is interval notation something we've talked about before? We have, but we didn't use the vocabulary word. Okay? So this is what it looks like. It's everything less than 58. So it goes all the way this way. And when it gets to 58, it's not included, so it's a parenthesis. You recognize this, don't you? We just didn't use the vocabulary word last time. So now you know what interval notation is. This is set builder notation. This is interval notation. Sometimes this is called inequality notation, just depending on what book you're using. Do you have any questions about this? Okay, so you have those problems to do. Hopefully you can get them done before you leave. Peace.